Hey guys, just a couple of questions we've got from 12C here that a few people have sent through, questions 4 and 5. The first one, some of the largest tides in the world are observed in Canada's Bay of Fundy. The difference between high and low tides is 14 metres and the average time difference between tides is 12.4 hours. Find a sine model for the height of the tide in terms of the time. Alright, some things we can do here, some things we can't. Their answer you'll see is underneath here, and they've given 7 sine 0.507 bracket t minus 3.1. How did they come up with that? First problem we've got is they don't tell us at any stage what the lowest point is, what the highest point is, the mean height, tide height is. So here they're suggesting that a tide can be -7 metres. Doesn't make sense for a tide to be at -7 metres, does it? It can be 7 metres below sea level. Doesn't make a lot of sense. So without actual numbers there, we can't get a lot of meaning out of it. If I was given this in, say, a maths assignment where you had to make some assumptions at the start, or even in an exam, I might say assume the mean, the minimum height is 2 metres, and just go. So then it varies between 2 and 14 metres above that, so 16. That would be one way you could do it. In this one, they've said the mean height is 0. So what they've really got here is a sine function of the variation about the mean tide depth. So that's just something that they've got there. So it's not a great question because they haven't given us all the information we need. But we can see there for why the amplitude is 7, because it's got to go 7 above and 7 below the minimum value. So we're happy enough that we can sort of see how they've used that 14 metres to get the +7 and -7 there. That's the first thing. The next thing, the only other bit of information we're really given is the time difference between high tides is 12.4 hours. So if you imagine that continued on to a next high tide, 12.4 hours, so we've got a period. So if we've got the period equals 12.4 hours, remembering the period is always going to be 2 pi divided by b from that general form we looked at today. A sine b bracket x plus c, etc. So 2 pi over b, don't like having two equal signs on one line, equals 12.4. That we know is true. Multiply by b and divide by 2.4, and I've got, 12.4, I've got 2 pi divided by 12.4 equals b. What's that going to give me? That's going to give me pi divided by 6.2 equals b, and that is the way I would leave my b if I was writing this in an exam assignment or anything. Beautiful exact number, can see it in terms of pi, makes a lot of sense. If you work out pi divided by 6.2, I think you're going to find 0.507 is roughly what you're going to get there. So that makes sense. Now they've got this strange shift of 3.1 hours. They're assuming that at midnight, or at the time they started measuring the tides, it started at a minimum. There's no reason for them to assume that. If I were doing it, I would have just said assume it starts at a mean height and not had a horizontal shift, a phase shift. It would have made it much easier. We could easily sketch our graph in here. And that's the same graph just shifted back to the starting point. And that would have been a lot easier, wouldn't it? There's no reason for them to have shifted it. What they've done is they've just arbitrarily decided that's what happened. So it's a little bit of an annoying question there. Some of you got to hear that in class, some of you didn't, so that's fine. If you can see how they got the 0.507, which should really be pi over 6.2, we can sort of make sense that the amplitude must be 7 because it's the difference between high tide and low tide, and then divided by 2. You've done well. There should be a d value on there that we should add, but we've got no information to determine it. So we can't really do anything from there. It does sort of lead us into question 5 though, so it is useful to have seen that, because question 5, we've got a similar situation. We've got a light that's going round and round a Ferris wheel, and we want to model the height of the light at any time. Maybe you're a sniper and you want to take someone out who's sitting in there, or maybe just take the light out so that no one can see what you're up to. Who knows? Whatever. There could be a reason that you want to model this accurately. Again, they've said here, assume that at time 0 the light is at its lowest point. So we can see that there. Assume at time 0 the light is at its lowest point. So that would be, in fact, following this graph that they've got there. That sort of pattern, isn't it? It's going from its lowest point. It's going to, as it goes around on the Ferris wheel, it's going to go up to its highest point. It's going to come back down to its lowest point once it completes a full period. But we've got a little bit more information, don't we? We've got the minimum height that the light is ever going to reach is 2 meters. Then we've got our amplitude here. This 10 meters is telling us it's going to vary 10 meters below that middle point there, the axle, and 10 meters above it. So it's going to go from a minimum of 2 up to a maximum of 22. And the amplitude, therefore, is going to be half of that 10, or the radius of the Ferris wheel, which makes a lot of sense. So if we wanted to come up with a model for this one, it's actually not too bad. So we've got the amplitude is going to equal 10. So if we're thinking about our y equals a sine b x plus c, remembering, unlike the answer they have up the top here, where they don't have the brackets around the whole lot there, that would actually be incorrect, because you just find the sine of 0.507, which is just a number, and then multiply that by t minus 3.1 if they don't have that extra set of brackets. They really need those in there. I expect you guys to have them in there. So far we can tick off the amplitude. That's going to be A, isn't it? We know that A is going to be 10. What's the vertical shift? What's our mean height going to be? Well, if it's going to have a minimum of 2 and a maximum of 22, we can even see a maximum of 22. Yep, we can even see here that halfway between those is going to be 12 meters. So it's going to be 2 plus 10. That's going to be the mean height, 12 meters. So if we know the mean height, or the central value that's already leading you onto the central axis, so we've got 12 meters there. We now know what D is. D is going to be 12 meters. That's pretty good. Next thing to work out is we're given one more bit of information here. The wheel takes 100 seconds to complete one revolution. So the period, we know something about the period. So we've got the period is 100 seconds, and we know that the period is always equal to 2 pi divided by b. Multiplying by b dividing by 100 will give me b equals pi over 50. So I know what b is equal to. So I've got A, I've got B, I've got D. Now it's just a matter of what's that shift? Well, a sine curve should be starting at the mean height. If you look again here at the answer for the previous question, we like our sine curve to start. It's easiest to track where the shift is by finding one of those starting points where it starts and we're going up and then down. Now that is going to start right here. Did it actually say which? Well, it didn't say which way it rotates. I've sort of assumed it's going that way. And it's going to get to that mean height after how many seconds? Well, a quarter of 100, because that's obviously a quarter of the way around. So 25 seconds, it's going to be at that point. So my graph is going to shift and not really start the traditional sine pattern where we can see the shift until 25 seconds. So 25 seconds to the right, so it's got to be minus 25 for C. So C is going to equal minus 25. And therefore we've come up with at least one of the possible models. So we're modeling the height, so why don't we call this h of t equals an amplitude of 10. We've got a sine model here, so that's great. I'm going to rub that out and try again, because I've just realized that that is going to go straight behind my lovely face, which I wouldn't want you to miss out on while you're watching these videos. That might make it just so much more boring for you. So now I'm pretty slow on. Still getting the hang of this new tablet, but that's all right. I'll just delete those and I'll write it a little bit more to the side so you don't miss out on the joy of seeing me. Need to get the pen back. Come on, back you come. There we go. So height at any time t going to be a value is 10. We've done a sine curve here. B is pi over 50. Now we don't want to just find the sine of pi over 50. It's pi over 50 multiplied by some value of x. which in this case is not going to be X. It's just controls and that. It's going to be T because we're doing this in terms of time. I want to shift to the right by 25, so I've got to be minus 25. That's what I wanted there. And then shift the entire graph up by 12 meters. So that should be what we're after. Let's go to Desmos and see if it's anything like what we think it's going to be. So I've come over here to Desmos and I've put the equation in. You didn't need to see me typing. I thought that'd be a bit boring. And we can see that it makes sense, doesn't it? It starts at a height of 2 at time 0. After 100 seconds, we've completed one period. We're back where we started. After 50 seconds, we're at the top. If I wanted to check the mean height being 12, if you whack in a y equals 12, it makes it really easy to see. And was it after 25 seconds that it shifted? Yeah, it was. So that's pretty much exactly as we expected it to be. Now, interestingly, if I was given the task of modelling the height of that light, I would never have chosen a sine curve because it's really annoying. Having to do that horizontal shift is silly. What I've really got here is a cosine curve that's been reflected in the x-axis before it's been shifted, haven't I? I've got an upside down cosine curve. So if I was going to do that one, I would have had said y equals, well, it's some sort of negative cosine function in terms of t. Now, we haven't finished yet, have we? Because we've still got to have that vertical shift of 12. We've still got to have the period being 100, so that means I need a pi over 50, which didn't quite work there. Let's just see if I can introduce a bracket there and a bracket around it, and now I can put another bracket and go pi over 50. Make sure the second bracket closed after that. That's looking a bit better. Now I've got to sort out that amplitude too, didn't I? I needed the amplitude to be 10. Lo and behold, I've got the same graph, haven't I? Remember how I said there's an infinite number of possible graphs that I could put there? There's another one, but to me that's so much easier because I don't have to worry about that horizontal shift. So if you can see it starts at the bottom, goes to the bottom, I'm always thinking a negative cosine graph. But either way, you've got the answer there that helps you. Keep the questions coming. It's really good to see lots more people ask me questions. Keep up the good work. Cheers, guys.